everyone. Okay. Whew, it was a bit of a scramble. My co-working stream kind of like ran up against this a little bit, so you'll have to bear with me as I get everything all set up for tonight. But how are all of you? Hello. Hi, Mediocre Gamer, and To Confuso. Hello, and hi, Cootie Juice. How are all of you? How's it going? How was your Monday? Mine was really productive. Obviously, if you stop by the productivity stream. Hi, Strawberry Jesus. Okay. Deep breath. Rushing from like the end of work and the end of productivity streams. Didn't have time to eat dinner, so a little bit, a little bit in a rush. All right. So, I'm extra excited tonight because we're going to talk all about pi. So we'll take a little bit of a break from algebra just for a little bit. And we're going to do some pi today. And in fact, I'm going to walk you through one of the really famous ways to approximate pi. And there will be code. But don't fear, don't run away. So if code isn't your thing, I wouldn't worry too much about it because, this is like all messed up. There we go. I have to turn my camera a lot for the productivity streams. But anyway, if code isn't your thing, don't worry. This will be very, very readable, and you can actually very easily follow along and do it in Excel. So if that's more your thing, you'll be able to do that as well. And hi, Galactic Stoner and Strawberry Jesus. Mediocre Gamer, you say that you sat in your car for an hour playing Slay the Spire. Nice. I don't have my Switch in here, but that's been my game lately too. my stress relief source. All right. Well, what did you all do for Pi Day? Did you celebrate in any way? Getting my notes. Where can I put these so I can see them? Put them here. Oh, I didn't even know that it could be on your phone. Don't tell me that. That's dangerous, Mediocre Gamer. Extra, extra dangerous. And I'm so glad you say you're having a great last 2 days. Well, hopefully your streak continues. I think it's been a good few days. I got to cook on Saturday, and I love cooking, so that was really fun, and it was beautiful, and got to grill. And then yesterday, obviously, Science Sunday, and today Math Monday, so, I can't complain. Hi, Granafire. You had pizza on Pi Day, so did I. The pie, in certain regions, right? Totally counts. Since I cooked Saturday, I should have thought ahead and made a pie, but I didn't really have the energy to do anything super fancy yesterday. So ended up just getting delivery pizza and being like, close enough. Totally counts though. Completely counts. In my humble opinion, at least. All right, so let me see here. Usually for the first little bit of stream, I like to give folks, a chance to come in, ask questions about any of the content from previous Math Mondays, or if there's something that they're confused about, or maybe I made an error that I never corrected. I like to start out with just a little bit of casual math conversation, and if you have any questions, if there's something from previous streams that you're still stuck on, you don't understand, now is a perfect time to talk about it. So I think so far in algebra, we've covered variables, expressions, single variable equations. We just started some linear equations with 2 variables, and we're going to do systems of linear equations next week. Whew, had to remember that today is Math Monday, and we're not doing it tonight. Let's see, what else have we done? Some graphing, some inequalities. So lots and lots of good stuff. Hi, Def Hacker, how are you? Long time no see. Do I seriously have... Okay, no, that's just a scratch on the glass. I thought it was my dog's hair because I love him dearly, but his hair ends up literally everywhere. Hi, big jugs of a big jug sofa. And Raphael, hi, how are you? Oh, well, thank you, Def Hacker. I'm sorry you're exhausted, but thank you so much for stopping by. Feel free to lurk, you know, do it in your PJs. Would you do a math stream for Tau Day? Which Tau? I say that because Tau to me means something probably that it does not. Tau being which use? The golden ratio? Is that what you're thinking about? I hear Tau and I think something from general and special relativity. So, I'm doing well, Divine Dev Studios. How are you? Why not? We could, yeah, let's do that. And well, June, there might be some life changes coming up for me that mean I might have to take a little bit of a stream break around then. We'll see. And Big Jug Sofa, you say the replays of machine learning are amazing. What's the next project? So I'm working on a fundamentals of data science. What I've realized is that for busy weeks for me, I can squeeze about one prepped stream in a week. And so lately that I've been putting my focus on Math Mondays. But I have a series of machine learning streams coming up that are sponsored by Microsoft. And so I'm going to be using Azure and we'll be doing a bunch of different machine learning projects on Azure. So that's really what's coming up. I'm hoping to do at least one of them in March. So if you are, you know, if machine learning is your thing, stick around because that's what we'll definitely have at least one of them in March. Hi, Aaron Tier and Matthew Escalin. Thank you so much for subscribing and helping me get closer to my birthday goal. My birthday is next week, so I'm extra excited. Hi, Katya. And hi, Nobenberg. I know, so many of you from the productivity stream. It hasn't really been that long. I thought I gave myself enough time, but then I got a little distracted with finishing up some code from work. So, and thank you, Joshna. And Big Joke Sofa. This is not a supernova. This is just like a pretty sort of spacey looking background. I ended up picking it during Machine Learning Miss because it had green and red, and so I thought that was kind of like holiday colors. But it's not real. But I do think it's pretty. If it were to be an object in space, it probably would be a nebula. So, but it looks really pretty. All right, so let me find my stylus. Here's the stylus, got that, alrighty. And let's get this whiteboard all set up. Move, no, now my notes are, where am I supposed to put these? Okay, those will go there for now. And let me get our whiteboard all set up. All right, here we go, whiteboard. And just gonna move a few things around, like me, get me out of the way here. And then, yes, Def Hacker, I am going to help Volcano Doc with her closed captions. So do not worry, that is the plan. Why is this red? Sync status error. Oh no. Well, Microsoft, I've heard a lot of Microsoft services are experiencing some issues. So that's okay. We don't need them. As long as this works. Pi. MS authentication is down. Okay, that's good to know. Thank you, Aaron Tier. And third tier, I noticed, yeah, you did a redemption for Stellaris. I love Stellaris, so I'm extremely excited to play some of that on stream. I also I do want to play more Dyson Sphere Program. Okay. What is pi? Let's start there. And I know probably plenty of you have an idea about what pi is already, but let's start to fill this in a little bit. I need to make that redemption the amount of points for it a lot higher third tier. I'm like so behind on the games I need to play. Oh, that's tough, Derp and Stiltskin. So Microsoft's down across the board. Ooh, yikes. Tell them that you can derive the equation for a circle circumference with the definition of pi. Yes, so we're actually going to talk about pi's relationship to a circumference. We're going to do some code even, but I warn you ahead of time. This requires my art skills a little bit, so I'm sorry. I'll do my best. I promise I will try so hard. I practiced like setting up the proof and everything, and like, you know, I drew lots of pictures to practice to make sure that I like, you know, wouldn't make a fool of myself. So we'll see, you know, we'll see how it goes. I'll probably still make a fool of myself. But thankfully all of you are so patient with me and my questionable drawing skills. All right, pi. Who has an idea? What is pi? Like, even if you tell me like the value, like what do you know about pi? Let's see. What do people already know? Because that's a great place to start. It's always great thing to start with what you know when it comes to math. Haha, Zug Addict. And let's see, Martin Eden. Okay, so you've got 3.1415926. I only pretty much know it to the 9, so I'm not one of those people that memorizes a whole lot of digits of pi. But, and yeah, 22/7. Approximately, this little like tilde in math means approximately. And mediocre gamer, yep, you can use it used to calculate, sorry, it's been a long day, calculate the circumference. So the perimeter of a circle, we have a special word for that. It's called the circumference. Perimeter of a circle. All right, handwriting check. Is this legible? I can try to be a lot neater. I'm trying to slow down and be very neat, but let me know if it is not readable. Ooh, Divinity Boy. Yes, good, thank you. Oh, really quick, mediocre gamer or the area, oh, both, yes. But Divinity Boy brings up something really great, which is it's an irrational number. What does that mean? Does it mean that it's like emotional? No. So let me just actually move some things around here. Oh no, where did chat go? Hold on. Oh no. Shoot. Crap. Oh no, Streamlabs. I pressed a button and chat disappeared. Hold on, my dears. How do I make it come back? Oh shoot. Notifications window? No. Oh no. No. My dear friends. Well, give me a second. I'm just going to pull up the stream in the browser. Momentary delay. I'm sorry, friends. Creator dashboard. I need to be able to see chat. There we go. All right. But it doesn't let me see a lot of chat, so that's frustrating. I don't know what happened. I just clicked something accidentally and the entire like chat just disappeared. So I will troubleshoot that a different time. But no, Big Jug Sofa, there's no annoyance, I promise. I'm here to answer questions. Like that's literally why I stream math and science. You say you're really into physics and programming. For some reason you can't study if the lesson itself is not fun. So, and you ask, can you get a job as an astrophysicist without a degree? So with astrophysics, no. And I'm not trying to shut you down, I promise. Like there's plenty of wonderful careers in tech where certifications or simply experience and demonstration of skill is enough. but astrophysics is a very academic field. And so really you do need the degree to be able to make like the relationships you need to do research. I don't agree with it. I don't, but unfortunately you really do. You need the degree for that. But if you say that you've taught yourself programming and stuff, there's a lot of developer and kind of like IT roles that utilize programming where I would say a degree is less critical. So hopefully, I'm sorry to it's really tough. I don't like shutting people down and just saying no. And if there was a way, I would do my best to explain it to you. But unfortunately, that's one of those very, very academic sciences where to really work in it, you have to have the degree. Okay. So, and lag adder, yes. Publish papers not just to gather renown, but to like demonstrate your capability as a scientist so that you can get more grants, you can get tenure, things like that. But that being said, if you really love astronomy, I definitely could see, there's a lot of citizen science projects. There's also, you could study something else like programming or machine learning or something and then apply it to astronomy. But yeah, unfortunately, it's just one of those sciences that's very, very, very academic. And Raphael, thank you so much for subscribing. Thank you. And thank you for helping me get closer to my birthday goal. I appreciate it. Okay, so irrational numbers. Let's talk about this for a second because we haven't really talked about rational and irrational numbers on Math Monday before. So rational, before we can define irrational, we need to define rational. And I want you to look right here. There's a word at the root of rational. And the root of rational is ratio, okay? And that's the key to understanding what a rational number is it can be expressed as the ratio of two integers. Ratio now. We can if we want. But what does that mean? So, and what is an integer? An integer is, well, let's start actually. I think it's a lot easier to start with whole numbers. And whole numbers, you probably learned this in school. Whole numbers are your counting numbers. So if if somebody says, let's play hide and seek, which is, all right, silly, but whatever. And you start counting 1, 2, 3, etc., right? So you've got whole numbers, which are 1, 2, 3, etc. And let me see, wait, does whole include 0? Does whole include 0? I don't think whole numbers include 0. What's the one that includes? Oh my gosh, it's been forever since I've had to think about a whole number. I think whole numbers don't include 0. Nevertheless, integers, I'm like 90% sure. All right, yes, natural numbers is, natural numbers include 0? Oh crap, I get natural and whole confused because I never ever talk about them. Let me make sure I get this right, actually. Natural numbers don't include 0. So that would be natural numbers, and then whole numbers include 0. Oh my lord. It's been a while since I've had to think about that. And Raziel, thank you so much for following. All right, so whole numbers are natural numbers, but we're going to include 0. That's right. Oof, goodness. And, oopsies, no. And then here comes the next, integers. So you can think about as you move through these definitions, we're adding something, right? We're expanding. So this is really natural plus 0. And integers are just whole numbers plus your negative numbers. We always hit that naturals with zero, naturals without zero, the university explicitly distinguish between them. D stool. Okay, that's good to know. You know, sometimes I find it a little pedantic, but I think it's important to be able to have those sets of numbers later in math. Nevertheless, now that we have a definition of integers, you know what rational is. So rational is, you know, all of this stuff plus numbers that can be expressed as a ratio of two integers. And you might ask, well, wait a minute, 1, 2, like how do we express those as a ratio? But then just remember kind of some of what we were talking about with our identity properties, and that 2 over 1, here's a ratio. But also still holds true for 3/2, you know, 5/7, etc. Hi Carlos, how are you? It hasn't been that long, has it? Welcome back. And remember that integers are negative as well as positive. So your rational numbers can be negative as well as positive. And so an irrational number, and this is our important thing for today, irrational, they cannot be expressed as a ratio of integers. So those of you who were here a little earlier are going to remember that we talked about an approximation for pi, 22/7. This is a rational approximation for pi. So if we don't want to have, you know, this never-ending decimal, then we can give a rational approximation, rational because it's a ratio of two integers. And pi is irrational. Hi Green Ghost and hi Prutz. So you define naturals as starting with 1? Yes. And whole numbers start with 0. There's a little bit of confusion there on my end because I always swap the two. But nevertheless. And I think I said hi Green Ghost already. But nevertheless. And yes. Let's see. Did I miss any questions? My chat is a lot smaller now that I accidentally closed it in Streamlabs. So let me see. Oh, I can pop this out. That might be helpful. Let's do that. And wait, what are whole numbers and integers? No worries, Prutz. Okay, so natural numbers, you can think of these as your counting numbers. So this is, you know, 1, 2, 3, etc. And whole numbers are your natural numbers plus 0. And wait, am I still swapping it? Because Torsavance, you say natural numbers include 0. I had it the other way around and then someone corrected me, so I figured I must have swapped it. Let's see. Whole numbers include 0. So, yes, 0 is a whole number. So natural numbers do not include 0. All right, had to just double check, and no worries, Prutz, if English isn't your first language. They do have different meanings in English. So your natural numbers do not have 0. Your whole numbers do have 0. And your integers include negative numbers. As we move through each of these definitions, the range or the set of our numbers is getting larger. So here we just have, 1 to infinity. But in our whole numbers, we start at 0. And in integers, now we're including all of the negative numbers as well. And a rational number can be expressed as a ratio of two integers. Yes, and Def Hacker, that's great. like a little ahead of where we are now, but of course you're a mathematician, so you're like on top of this. And let's see, -1, -2, -3 are not whole. They are not fractional, you're right, Prutz, but they're negative. And whole numbers do not include negative numbers. So some of this is like, it's a little prescriptive. We need words to be able to describe different sets of numbers in math. So we need a word to describe, the numbers that are counting numbers that feel like, the intuitive amounts that we talk about. We need a word for, and let's see, whole means not fractional in English, right? I wouldn't say no. So I think what you're thinking of, not fractional, is irrational. So cannot be expressed as a fraction or a ratio is irrational. Whereas rational can be expressed as a ratio of two integers, which is the important thing there. And Danger Nub, thank you so much for following. And let's see, but integers, Def Hacker, integers are not fractional as well. So that is the difficulty there, right? Okay, so moving on from sort of these definitions, there is an exactly, Zug Addict. You can always think of one of the sets as being a subset of the next one. Absolutely true. Okay, so since we've done some algebra on the channel, I can also give you another cool thing about pi. And thank you, Random Sebastian, for following. Pi is also, you ready for this? Pi is also, I'm going to spell this wrong. Hold on. Transcendental. I still spelled it wrong. Good Lord. Transcendent. I can spell it when I'm not having to write it on the blackboard. And let's see. Can I prove that? Are you thinking about the sets that outside a little bit of what we're talking about tonight, Zug? And Prutz, I mean, if you just Google like an intro, intro algebra or pre-algebra textbook in English, you will see those definitions. So transcendental, no, it's not tough. Or you mean to spell? It's not that bad, but it's always like when I'm writing on a blackboard, sometimes my mind is a little bit ahead of my hand. So you're getting transcendental work done this week? Haha, love fun. Okay, so what does transcendental mean? Well, so transcendental, like irrational, is described as not something. So in order to understand what this is, we have to first describe the thing that it's not. And so that means we have to talk about algebraic numbers. And algebraic numbers, if you remember from our wonderful algebra lessons in Math Monday, and thank you, Rai Bonmo, thank you so much for following. Algebraic numbers are numbers where we can kind of like, I don't even know if this would work. Probably not, but whatever. So algebraic numbers, in this case, x is an algebraic number. It can be expressed as an algebraic equation. Yep, Pretz, like, I make some mistakes sometimes, but, once I really talk about this kind of stuff, I do know what I'm talking about. So we, this kind of algebraic equation, x is an algebraic number. Now, transcendental means not algebraic. So that means that pi cannot be expressed as a polynomial. And I know that's a word that might be new to some people. So a polynomial is kind of like an equation like this. We will be going over it in more depth. In algebra, we haven't gotten there quite yet. Hi, Eric Inham, how are you? And yay, hi, that math teacher. Yep, no, integer and whole numbers are different in English. So integers include negative numbers. Okay, So that's another a cool fact about pi is that it's transcendental, which makes it sound like magical almost, but not magical, just not algebraic. Is that polynôme in French? Probably. I speak a little French, but I have not done a lot of math in French. So hopefully maybe there's somebody else. I don't know if Mosh is here, but we usually have a couple people who speak French. And nevertheless, so, okay, so now we've learned a little bit more about pi, but you might know that pi looks like this, right? And it's called pi because this letter is the Greek letter pi. Okay. Why? Why pi? Why this letter? Well, I'm going to put on my linguist hat for a second. So, in Greek, the word parametros, which I have to remember where the accents are, parametros in Greek, perimeter for us in English, starts with pi. And because the parametros, or perimeter of a circle, what we call a circumference, is where our understanding of pi came from, the abbreviation or the shorthand in math for this number comes from the word for perimeter. Pruts, trying to learn Greek now. I had to learn, oh God, and this was years ago, this was in college, but I had to learn to be able to read the Greek alphabet and a bit of Sanskrit in some of my linguistics classes so that we could kind of read, at least sound out words, but I don't speak Greek at all. But nevertheless, the letter name sounds different in Greek. Probably, I don't know, I don't speak Greek. Okay, so let me see here. Make sure I'm getting all of my notes. Okay. Well, let's also talk about where pi came from. So now we know where pi's name came from. But actually, I'll start like a new little fresh area here. And Danny Loesch, thank you so much for following. Welcome to Math Monday. Where did pi come from? Let's see, I want to change up my colors here. I'll take some red and I want some green. Okay, let's go green. Hi, how are you? Welcome. And thank you, Aaron Tier. So in English, we do say pi, so I'm going to pronounce it like that because if I, talked about P all day long, I don't think people would really know what we were talking about. They might get a little bit confused. So, where did pi come from? So this is really interesting from kind of like a archaeological point of view. So, hold on one second. My windows are all out of order. 1 second, friends. I think I can minimize this and I'll just, I'm going to fake it. So I've got Streamlabs up and I'm just like, I popped out the chat from Twitch and I'm just putting it where it normally is on Streamlabs. All right. And let's see. Oh, that's interesting. So, Big Jug Sofa, you say that even though you're not French, you learn math in French. Do you mind me asking where you're from? That's really cool. I have to say, I'm trying to think what I've learned like history and literature and stuff in a foreign language before, but never math. All right, so where did pi come from? And like I said, this is kind of an interesting story. So some people think, and this is contested. Some people think that, and let's see, Pruitz, you ask, think about the number of elements in a list or an array. What kind of number is it, natural or whole? So the number of elements would be a whole number, and the indexing would be, in most languages, the index would be an integer. Oh, wait! So, hey, Big Jug Sofa. Aslama. I lived in Tunis for a while. So when I was talking about learning literature and stuff in a foreign language, I was learning it in Tunis. So, welcome. What part of Tunisia are you from? I visited mostly all along the coastline, and then we went a little bit to some of the, like, the central areas near the Sahara. But oh, you're in Sousse. Oh, Sousse is great. Oh, it's beautiful. Yeah. My undergraduate education was in linguistics, and my focus was North African linguistics. So this is many years ago, but I at one time I spoke Arabic and French quite well, and I was learning Tunisian dialect. I love Tunisian dialect. It is beautiful. But when I came back to the States and started to switch into science, I didn't speak it as much, so I've lost most of it. But it's so exciting to have somebody from Tunisia here, though. Oh, I miss it. I have to tell you, like, no matter how much I try, my Oja does not cut it. It still is not the same as having it in Tunisia. So, yeah, I loved it. I really loved Tunisia, and I was there in 2011. So pretty tumultuous year for Tunisia, but probably one of the most beautiful countries I think I've ever seen, because you can go from having mountains with snow to, like, your classic kind of Mediterranean coastline to the Sahara Desert, like, all in the same country. And I could show you, like, 3 different pictures from Tunisia, and they look like 3 different countries. They're beautiful, just beautiful country, and, like, really wonderful people. I have to say, like, that is the, like, most, I felt very safe to, like, weirdly enough, just walking down the street, I felt safer in Tunisia than I do in a big American city. But also, like, just everybody's so hospitable. There's kind of like a, I don't know, focus on hospitality in a way that I don't think we have in the United States. But yeah, I lived there for like 4 or 5 months and studied. So I went to Institut Bourguiba and studied Arabic there. And yeah, it was really fun. I love it. I've always wanted to go back. But so welcome. Yes, I did visit Gabes. This is such a wonderful coincidence. God, it's been so long. I can't, like I think about Tunisia still probably on, like, a weekly basis at least. Hi, where is X? Welcome. But this is, I have to say, I don't think I've had some other North African, like, Maghrebi folks in chat, but I don't think I've ever had anyone from Tunisia. So, this makes me so happy. And you Muse, thank you so much for following. Okay, math. Where did pi come from? Sorry, I have to, like, I went off on a tangent because I'm so, so excited. Yeah, here, I'll DM you, but I love harissa, and the harissa that you get in the United States is terrible. So, okay, small story time, then we'll go back to math. But when I was coming home from Tunisia, my luggage was way too heavy. So, like, 10 minutes before my flight is supposed to leave, I'm on the floor of the airport in Tunis, in the capital, and I'm, like, throwing away my clothes because I'd rather throw away my clothes than leave behind, like, the cans of harissa that I have stuffed in my suitcase. Because I wanted to bring a lot of it home. Not sure if I declared that. I don't know if you have to do special stuff for food and customs, but whatever. But I tried so hard to make it last, but I cooked with harissa, like, everything had harissa in it. And I miss it so much. I miss so much Tunisian food. Like, just such good food. But, oh, yes, thank you, Lordly Dawn. I will wait until Where is X is in chat. I thought I saw Where is X earlier, though. So, you probably, Mediocre Gamer, you both actually probably, used the command at the same time. But, thank you, Big Jug Sofa. And Summer Deception, welcome. Thank you so much for following. Also, Big Jug Sofa, join the Discord. We actually have a channel, a language learning channel, where there are some folks learning Arabic. If you feel like joining, that'd be great. Oh my goodness, this is such a wonderful coincidence. I know, commentator. Shh. All right. Okay, pi. Let's get back to pi, or I'll talk about Tunisia all day long. Let's see, Raymarch, how do professional streamers do the rating thing? I always miss the part where the rated streamer says thanks for the raid because I mess with browsers. Yeah, so hi, Where is X? Thank you so much for the raid. Yeah, go relax. Have a good evening. I hope you had a wonderful stream. But yeah, Raymarch, I usually when I raid somebody, a lot of times I miss the thank you as well. That's why I have the raid command, to remind me to wait until the person kind of comes into chat so I can thank them. Because a lot of times I miss like the excitement, you know, especially because I love to raid small streams. I always miss how excited they get, which makes me sad because I like making people happy. So, okay. And hi, Abhishek, how are you? All right, so where did pi come from? So first I'll tell you kind of like, this is a little contested, but some, you know, historical or mathematical historians or historians of math believe that the pyramids of Giza, the Great Pyramid of Giza, which was, I wrote this down so I wouldn't forget, 2500 BCE, is proof of the need to at least have an approximation for pi. So a lot of people think that that's one argument for where, like, the earliest reference to pi. However, definitively, we do have, let's see, when was that? And this was in Babylon and Egypt. So in Egypt, you had and I looked this up for you, the Rind or Rind papyrus. And this lists a formula for the area of a circle that uses pi, as I would say, 16/9 squared, which is about 3.16. So even like, this is some of the earliest, you know, written history, and pi was there. Pi was there first. And so, yes, Abhishek, so you can, you know, we talked about earlier that you can have a rational approximation for pi that is 22/7. But I'm talking historically speaking, this is some of the earliest written record for pi and values of pi. But the cool part of stream that we're going to talk about tonight actually comes from Archimedes. So Archimedes was a Greek mathematician, philosopher, all the things. And I didn't get a date on that, but I want to say it's like 200 BCE, 150, something like that. And Archimedes was the first person to come up with a methodology for approximating pi with way more accuracy. And Archimedes is also the name of the owl in Disney's The Sword in the Stone. Good to know. And Jimmo, I have links blocked, but feel free to DM Loafbone. He's your mod, and if you DM him the link, he can like screen it and also post it. So, and no worries, that math teacher. Thank you so much for stopping by. And yes, Luke, the pi symbol does come from Greek. So we talked about that earlier. It comes from the Greek perimetros, which is the word for perimeter, because pi was first calculated in a way that relates to the perimeter or circumference of a circle. And so that's where pi comes from. Apparently Archimedes is also the name of the dove from the medic in Team Fortress 2. Cool. I don't play Team Fortress. And oh, this looks really interesting. Okay, I will read this later. Thank you, Jimmo. I love archaeology, and I love to kind of read those kinds of articles. So thank you. Learn some gamer history. Exactly. I play a lot of video games, but I have not played Team Fortress. I know, Pro. It's that moment when the name Archimedes is better known from Disney movies than from mathematics. Poor Archimedes. The OG Archimedes, excuse me. Okay. So, same with Heisenberg. Wait, what? Who? Is Heisenberg in Disney? Or, no, wait, you're thinking about... What are you thinking about? I don't know where else Heisenberg is. Oh, Breaking Bad. Duh. Okay. All right, sorry. I knew the other Heisenberg first, so oopsies. All right. And commentator. Archimedes of Syracuse was a Greek mathematician, physicist, engineer, inventor, and astronomer. Yes, okay. So, you know, the Greeks, they did everything. Heisenberg is a Disney princess starring in Breaking Bad. Nice, low phone. Thank you. Thank you. Good to know. Let's recommend that for the children. All right. And so... previously, actually, so this would be under our little Archimedes bullet here. So previously, the way of approximating pi was done by taking a polygon, which is just poly, many, gon, side, so many-sided figure. So your triangles, squares, octagons, dodecahedrons, you smush all of that, it's a polygon. It's like the set of all the sided figures. Many angles, not sides. Is gon, oh, then what is side? Oh, crap, I think you're right, because there's a math term for side, too. Hi, Smallsy, how are you? And thank you, Aaron Tier. So many angled figure. But let's see. Ooh, you took off a week from work? That's great. I'm glad that you got like a rest and a break. That's excellent. Okay. Regardless, polygon is a figure with many sides. And yes, Aaron Tier coming in with the Greek. Thank you. Your friends are polygons, many gone, all your friends are gone. No, it's not the definition of a side in geometry. I could have sworn that there was a word for... I could have sworn that there was a word for side specifically, but it's also been a gazillion years since I've done geometry. But you also might see, while it looks like the Greek is technically angled, a lot of times you're going to hear people talking about a polygon being a many-sided figure. So, sorry, Greek. And let's see here. I'm catching up on chat. Lateral, but that's Latin. Yeah, let's not mix. Oh, it makes me sad when people mix Greek and Latin roots. All right. So one of the ways that historically people learned to approximate pi is by approximating circumference by taking a polygon and drawing a circle around it, inscribing. So inscribing a polygon in a circle. And so what that looks like is, oh gosh, here we go. I'm gonna try to, let's inscribe a square because that's a little bit easier, maybe. I'm not an artist. So here's our polygon, and then it is inscribed in a circle. And so you can see that its vertices intersect with, really does not want me to draw over that. Okay. You can see that its vertices intersect with the circle, and that's how, you know, we've inscribed our square. So you can't just like, no. So we have an inscribed polygon. And there is plendra. That's modern Greek. Okay. A polygon is also what every GPU renders to make models. Yes. So polygons, polygons have in remote sensing or kind of like geospatial work, you'll hear people use polygons as well. Okay. So if we don't know how to calculate the circumference of a circle, what we can do is we can inscribe a polygon and kind of guess and calculate the perimeter of that polygon, and maybe it gives us a little bit of an approximation. Polygon is also a gaming website. I feel like this is one of those memes on Twitter of like, okay, I'll bite. What's a polygon? Okay, so the difference being, so this was even before Archimedes. This is how mathematicians knew to estimate the circumference of a circle. But Archimedes came up with a really cool method for taking this idea, iterating on it, and having a more accurate approximation of pi. So first I'm going to walk you through some of the setup here on the whiteboard so I can draw some pictures and stuff. And then I'll show you kind of how we could do this in code, because we're going to want to iterate. We're going to want to have more and more sides, because if you think about it, the more sides we have, the closer we're getting to the circle. So ideally we'd want to be able to have more and more and more sides, so we get closer and closer and closer to that real value of pi. Okay, so let's talk a little bit more about Archimedes' approach. All right. So let me get my notes here so I can remember. I like named things so that I would be able to reference them later. So let's get that. You're just here for the galaxy pen. That's fine, Ray March. That's fine. All right. So we are going to start with, didn't Archimedes really love triangles? Lots of people love triangles. And Luke, I'm not sure what you're talking about. I feel like, let me get some more water. Hold on. I feel like the drawing tablet is working just fine. Have I missed something? I mean, Pythagoras technically was also the triangle guy, so. Miss, will this be on the test? Generic crew, there are no tests. This is just the love of math. All right. So let's talk about Archimedes' approach to estimating pi. Oh, shoot, I can't see my pens. All right, there we go. So give me a second. I'm gonna draw Derpin Stillskin. Thank you so much for gifting 5 subs to the community. IHVH, Wallaber, Dust NZL, Durandals, and District 10 Mushrooms. Now you have subs. You've got cute emotes of my dogs. And Secret Agent, thank you so much for subscribing as well and for getting me really, really close to my birthday goal. Thank you. Nope, Luke, so it's gonna show the mouse cursor. I'm controlling it though with my pen. So you only care about the Pog emote. Okay, well. See, I thought about having the stream like extension or whatever, where if you put a lot of emotes in chat, like it makes them bounce around the screen. And then I realized that for our poor viewers on YouTube, that would probably be a nightmare. So, and let's see. When is my birthday? March 22nd. So next week. But thank you for subscribing anyway, even if you didn't notice. Okay. And Droshna, thank you so much for paying forward your gift sub. Divini Boy, now you have a sub as well. Now that whenever I see numbers in the 90s, like people with a name that's like 96, 98 or something, I wonder if that's their birth year, and then I feel old. Nevertheless, thank you so much, Droshna. You guys, so nice of you. Thank you 1,000,000%. Skino, pi equals 3. I'm an engineer. It's easier for you. Welcome to astronomy. Pi's like, what is it? Not even 3. I mean, sometimes in astronomy, you're just like, pi is 10 to the 0. You just approximate like the closest magnitude. But, Raymarch, so do these videos get edited? So for people on YouTube, I crop out the kind of intro where I'm setting up the stream, so like just kind of the starting soon screen. But everything else is in the video, but they can't see chat. So I try to make an effort to say what chat, like say the questions out loud, so that people will be able to know what's going on if they follow on YouTube. But let's see. All right, nice, Steph Hacker. No, nobody's old. Everyone is wonderful. But let me think. There was something else I was going to tell you all. Oh, okay, Luke. So yeah, no, this is an XP pen drawing tablet, but I think the difference here is that like this tablet doesn't have a screen, so I'm like, this is connected to my computer, so that might be some of the difference. And yeah, Torsvance, that might be a great like future Math Monday stream for, you know, celebrating Pi Day. I thought let's go with it, you know, the OG approach. But all right, old is not a bad thing. Exactly, Zug. Exactly. Oh, and we have a hype train. Thank you. Hopefully we'll get some cool emotes out of it. So thank you so much. Let's see, both to Droshna and also Secret Agent, and also, of course, Derpin Stiltskin. Thank you so much for starting our hype train. Oh, they're wonderful. Okay. Hi, Spawn. How are you? Hello, Phone. 3 dog treats. Thank you. Cute little emote with those. And yeah, Divinity Boy, Pi Day was yesterday, but you know what? It's fine. We're rounding. We're aggressively rounding. And Spawn, it's so good to see you. I haven't seen you in a while. How have you been? Aaron's here. Oh my goodness. Thank you so much for 5 more gift subs. Pluto, Riddler, Prutz, good. Prutz, you got one too. Alex Warhawk and Matt. Wait, Mom. Hi, Mom. Incella Mom is here. Behave, chat. Be good. All right. Behave. I think you're gonna love this, Mom. So, I'm going through the Archimedes' way of approximating pi. So I thought actually this would be something really cool that you would like. Yay! I love when my mom is here. Those are the best streams. But thank you so much, everyone, for the subs, the gift subs. You all are wonderful. Thank you 1,000,000%. And Dux M, thank you so much for following as well. All right. Behave, chat. If my mom's here, you all have to be on your best behavior, okay? All right. Archimedes Approach. So let's first talk about the, let's set up some of the simple stuff. So we're gonna use, let me pick some good colors here. What are some good colors? Light blue would be good. And good, we've got yellow. Let's do the dark blue and yellow for Yes, okay, that'll work. All right, so let's take a hexagon. Okay, a hexagon is a 6-sided figure. And this is an approximate drawing. Approximate. I'm not an artist. But I'm trying my hardest here. All right. Okay. A hexagon. And just like before with our square, we're going to inscribe this hexagon into a circle. Now, it's a lot harder for me to inscribe the hexagon, so I need it to... Ooh, well, we made a little bit of a goof there. Who cares? All right. Woo. If we erase it, no one ever knows it was there. Ha! All right. Okay, so we have now inscribed our hexagon into a circle. And we're going to use this hexagon to approximate pi. So one of the things that we need to do... Oopsies. Let's draw straight lines. Oh my gosh. Hold on. Oh, I did well on a piece of paper. I'm going to blame my tools. Whatever. All right. Close enough, right? I'll just use my straight edge. All right. So now we've divided our hexagon into some triangles, okay? And let's see. Prutz, you ask, that's the lower bound for pi, right? Well, I think you can answer this yourself, right? Is the circle larger or smaller than the hexagon? The circle's circumference will be longer, right? Longer than the perimeter of our hexagon. And so in that case, yes, that would be we are going to get a value that is smaller than pi. Thank you, Aaron Tier. Coming in clutch with the Greek word for side that I wanted before is hedra, so as in dodecahedron. Okay, that makes sense. I always thought of that as face, but that's probably... I always thought hedron was for 3D shapes, but I could be, mistaken. It's a nice drawing of the first order. Okay. No, it is face. It is face. Okay, yeah, all right, so that's what I thought. All right, so a couple of things here. One of the cool things in our wonderful hexagon, right, is that, this side length is equal to this side length is equal to this side length. So this is actually each of these triangles here. I'm gonna outline one in green for us. It is an equilateral triangle. That means all of the sides are the same length. Can I speak and read Greek fluently? I cannot. I can read Greek badly, and that's about it. So this is an equilateral triangle. And let's think about the circumference of the hexagon here, or the perimeter of the hexagon. So whatever the side is, so if we say this is S, right? It has 6 sides. So our perimeter is going to be equal to 6S. And our diameter, right? So the line that cuts through our shape is going to be 2S. Okay? And so we know that we want to get the best judgment for the ratio of the circumference to the diameter of a circle. So if we kind of try here and we do a ratio of the perimeter to the diameter, we would get 6S over 2S, which is 3. So we start with an estimation for pi as 3. Not bad, right? Just for a really quick doodle and a really quick, not bad. So we're already so much closer. But let's make it a little harder, all right? Okay. So I'm going to take this little triangle here, Well, remember what I said earlier, where the thing we really want to do is we want to increase these sides, right? We want to get more and more sides so that we get closer and closer to the real value of pi. So for that, the easiest thing to do would be to double the sides, because then all we need to do is kind of cut each of these in half and have two sides instead of one. So let's do that. So what we're looking at is, let me find a color I haven't used yet. So what I'm talking about is drawing a line straight through that cuts this in half, and then I'm gonna zoom in on this because it's gonna be really hard for me to describe without being able to zoom in. So I'm gonna zoom in on this triangle, okay? This is our triangle, okay? And then we have, remember, it's inscribed in a circle. All right, so let's just say, I know it's a little wonky, but let's use our imaginations. And I've said that we're gonna cut it in half. Because ideally what we want to do is I want to create two sides where there used to be one, right? Because then we'll get a 12-sided figure instead of 6. All right, so that's what the light blue lines here would be for 12 sides. And the green is for our hexagon, so 6 sides. And Shipmaster, thank you so much for following. Picture-in-picture zoom. I'm trying here, okay? I worked very, very hard to make some pretty pictures for you. So we have our first approximation, which is 3, right? But how would we get to a 12-sided figure? So let's say that for ease of math, we're going to say each of these has the value 1, okay? And now let's figure it out. So we know, I'm going to erase this 6 sides just for a sec so I've got a little bit more room. And hi, Icy Yogi, no worries. Thank you so much for stopping by. Sleep is important, so I know stream times are not convenient for everybody, so thank you so much for stopping by. Okay, so we've got sides, value 1, right, because they're all equilateral triangles, so we also know this base right here is also 1. And because we've cut this triangle perfectly in half, even if it doesn't look like it, we know that this right here, time to get some more colors here. The length of this right here is s over 2, or in our case it's 1/2, right? But if we're generalizing and we say this is just a side, it's 1 over 2. Here, the side is s. This is just whatever value this is, this base, over 2. Generic career, hurry up and move to the European Union for normal streams. Working on it. All right. So then, let's say I'm going to do some clarifying colors here so we can talk about different lines. Let's say that the line that gets this far is, let's call that A. Okay? And so that just goes from the kind of apex of our triangle, cuts right through the middle. And then we also have this other little bit here. And we're going to call that B. Okay? And that's what's going to help us figure out how long these sides, what the value, the length of these other sides is, to figure out what our new estimation for pi is. And yes, Aaron Tier, you absolutely got it. You got it absolutely. So let's figure out first a definition for A. So if I'm going to take this triangle and I'm going to redraw it for all of you wonderful people. I don't need blue yet. I need green. So this triangle right here with A, it's going to be a little tilted, but I'm going to use the same colors, so hopefully that helps you see which triangle we're talking about. This is a right triangle, So we know this is A, this is 1, and this is S over 2. Pythagorean theorem. Who wants to let me know what is A? Ha, I'm putting it on you. Also wanted to text my mom. Where's my phone? Oh, it's all the way over there. You all, tell me what A is. Well, I text my mom. Okay. All right, SOHCAHTOA. Nope, no SOHCAHTOA. We don't need trig here. We don't need trig. 1 plus S squared. Not quite, Torque. You're really close. You're really close. Really, really close, but you got a little bit of a goof. A little bit of a goof. Minus. And actually, for clarity, let's keep these colors going. I feel like this is helpful. We don't want to get into trig. Nope. No trig today. Nope. You don't want to sit here and start dealing with angles and stuff, not yet. Important unbiased and NP. All right. So we have a value now for A. We have an expression that tells us what A is worth. Now we need to figure out what B is. Now, as we've defined it, so as we've defined in our problem, we're curious about, let me draw it like that, please. No, it's being a poop. Hold on. We are curious about this circle that we've drawn, and as we've defined it, to make our lives easier, the circle has a radius equal to 1. Okay? So we know that this whole A plus B, we know A plus B, which is this right here leading all the way out to the circle, is 1. That's how we've defined it. So IHVH, there's a reason why I'm continually saying S, because as we increase the number of sides, the length of these sides is going to change. And so we need to distinguish between the radius of our circle, which is 1, also the side value for our hexagon, and the side value of future shapes. So we have to distinguish it. And yes, torque, absolutely. So in this case, not S, because S will be changing, and because it's varying, right? We're going to make it a variable, but we are going to keep 1 here because we know that our circle is not going to change. We've defined our circle. It is not changing. Our shape will be changing, so S will be changing, but the radius of the circle is not changing. Dr. Bugsy, thank you so much for following. All right. And so for that, let's see, what was I saying? Yes, we got that. So B then, have I written B in a color? I have. Let's be consistent. B equals, and if it helps, let me write 1 there in yellow. And we'll put yellow here so that you know this is related to the circle. And B is 1. Keep having to change colors. There we go, minus A. Right, because 1 is our radius of our circle. That's not going to change. And then I think this will help a little bit. I'll be clear with my colors. Okay. So, B is 1 minus A. Yes. All right. Let me just catch up with chat here. And Kitty Slayer, my birthday is the 22nd. The radius isn't the variable, Luke. So let's take a pause here because I think folks are getting a little confused. Open set, thank you for following. remember that we are talking about two different shapes here. We're talking about a hexagon to start out with. We're talking about our polygon, right? So it's the number of sides and the length of those sides is going to change. We are also talking about a circle. The circle is the shape we're really interested in. We want to know what is the ratio of its circumference to its diameter. So we know for a fact diameter's 2. But we don't really know a way yet to be able to figure out circumference. And so our first step, right, was to inscribe a hexagon. And we started out with a hexagon because the length of each side we'll know from the start, because a hexagon, when you cut it up like this, has equilateral triangles, and we'll know the length of all of these sides thanks to the radius of the circle. So remember, let's keep our circle and our polygon separate. Our polygon will be changing the number of sides as well as the length of those sides. Our circle stays the same. The whole point of having the circle, right? That's the whole thing we're trying to estimate. So as we kind of change this polygon and increase the number of its sides, we're going to get closer and closer to our best guess for a circle. Hopefully that clears some of this stuff up. And open set math hype. Good, you're in the right place. Definitely hyped about math. And nope, E equals MC squared. We're not doing that tonight. Not for here. Oh, you were in stream. Someone gifted you a sub heart. I don't know if my mom knows what that means. I'm doing a stream on where pi came from. I thought she was here. Okay, that's fine, Mom. Even if she just has it up to support, that's okay. I got excited. All right. So Rama talks. We can abstract having R for now. We need the 1 so that we know a value, so we can actually start to have numbers. Okay, so we need the 1, but that's how we're defining it, is like, let's see, can we figure out, because think about it, right? The ratio of the circumference of a circle to the diameter is gonna stay the same no matter how big or small the circle is. So come on, let's make our lives easy. If we make the radius 1, it becomes a whole lot easier. The math becomes easier, but we know that that final circumference divided by diameter value is not gonna change. I have R equals 1 right here, Rama talks, right here. I know complex numbers are really cool, Def Hacker. All right, hi MacGyver. Okay, so let's keep going. All right, so the other thing that we really need to define here is we have something else that we haven't defined. And let me see if I have another color. I guess we could use orange. So can I change the side of this? No. Okay. Doop, doop, doop. Doop, 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 doop. All right, I'll just redraw some of this. My picture on my notepad is in black and white, so I'm kind of deciding some of these colors here on the fly. All right. I know, I agree, Luke. I agree. All right, so our new sides, we're gonna call S2, our new side, right? Nope, Aaron Tier. This isn't like Photoshop or anything. It's a really, really basic whiteboard app from Microsoft. So it's very simple. If there is a way to do that, I don't know. I'm trying to keep it simple for myself. I don't want to have to learn a brand new technology. All right. So our new side is S2. So if we're going to keep figuring out our approximation of pi, we need to know the length of the side, right? Because we already know the number of sides. We're just taking our original hexagon, which I'll say n here, number of sides is equal to 6. But with S2, our n is 12. We know we're doubling the number of sides. And so in this case, we need to figure out, how does the length of this change compared to what we had before? So now we have another triangle. And so I gotta get all my colors ready for that. So we have, I'll try to draw it similar. Ooh, that's a little bit wavy, sorry. Okay, and so our question is, what is the value of S2? Final length bigger than the circle. Luke, not as long as the polygons are still inscribed. So as long as we're placing them inside of the circle, no. So who wants to tell me what S2 is going to be? I'll give you a hint. You've got another, oh wait, no, I drew this wrong. Hold on. Don't do it yet, no. It's, shoot. This is what I get for, no? Yes, no, I drew that right. No, I'm sticking, No, I drew it wrong. Hold on. Don't look at this. Nobody saw it. It's as if it never happened. Exactly, IVH. Yeah, I just caught that. I was like, wait a minute. So. I just did it literally the same, didn't I? Jess, I drew it right correctly here. Why do I keep doing that? Brain block. Hold on. So, yes. Oh boy, all right. Thanks for sticking with me. All right, what is S2? What is our new side length? Ooh, goodness. All right, it's been a long day. I know, generic crew, I had to fight. I was like, why do I want to draw the triangle this way? My hand just wants it that way. You know what? Well, it doesn't matter, maximal, because if I put the square there, it doesn't matter how it looks. I can just kind of be like, this is a right angle, regardless of how it looks. And yes! Yes. Mirabic and Torse, excellent job. So, oopsies, let's use orange. You got it, friends. Pythagoras is getting some work today. And I also know my colors. Okay, so now we have a way to figure out the length of our new sides. So we've got a couple different ways to do this. If you are like more of an Excel person, you can start to put these values into Excel and you can automate it that way. It would be a nightmare to do it by hand. Thank you, Archimedes, who did it by hand. But thanks to, modern life, we can just code it. Let's get out our Python land and let's do some Python. All right. Did I do all of the pictures? I did all of the pictures. We're going to be referencing these pictures. So, Skinno, exactly. All right, so, you know what? No. Give me a sec. I'm just getting a few things figured out here. So originally, I had set up the stream a little bit differently, but I think today that the best thing is going to be not to do this, and instead to do this, so we can see both. Okay, and I know my head's in the way a little bit, but at a certain point, I can't really help that. Oh no, where did chat go? Chat, my dears. Here's chat. Okay. All right, so this is just like a Jupyter notebook for ease, right? I am lost. Give me 1 second here. Where are my notes? New? Excuse me, computer. Where did I put them? So I've got to move all of my windows again. I really broke things, didn't I? All right. Okay, there we go. We're all set up now. All right, so don't worry about this. If you don't know programming, don't worry so much. We're just gonna sure got enough room here. Zoom in so all of you can see. So this is just so we can do a square root. So that's the abbreviation for square root. So let's think about this first. Let's take our example of having the number of sides is equal to 6, okay? And our side length is going to be 1. Actually, so like I said, we'll have our radius of our circle is 1. We're starting with 6 sides. Our hexagon, we just drew a hexagon. Don't worry, generic crew, it's okay. Big Jug Sofa, I usually just import Math 2. This is for readability. So Math Mondays, I usually don't have code. So for people who don't know coding, it's a lot easier to see just like the squirt than it is to see math.sqrt. So, well, Taurus, this is PEP 8 standard for Python. So I follow the standards for the language. When I code in C#, I follow those standards. When I code in C, I follow those standards. And when I code in Python, I follow the Python standards. So, all right. So let's think about this a little bit. I abstracted this quite a bit, didn't I? I know, right, Ray March? All right, so let's do this a little bit. So we know that our current side, our side length right now is also 2. I'm sorry, it's 1. Wake up, Jess, wake up. All right, it's been a long day. Here we go. So the first thing we need to do is to define that purple, the purple side right here. Can you all see that? Yeah, okay, that's still above my head. I'm also gonna just, no, don't do it. There we go. I think that fits a lot more of it on screen. All right. You still need me to zoom in a little bit? Hopefully that is enough. It's getting a little ridiculous. Yes, there we go. All right. Oh no, where did chat go? I need chat as well so I can answer questions. There we go. Okay. Hopefully this is more readable. All right. And, okay, so let's see here. Side length 1, radius is 1, the number of sides is 6. For now, we're just gonna start with the hexagon, okay? And so look at the purple side, right? We defined that as our current side length over 2. So we're gonna have our, I'm just gonna call it, how did I define that? We'll just call it S2. Did I call it S2 somewhere else? Yes, I called it S2. So let's call this half side is side length over 2. Easy, right? Okay. And then we know A, right? So we have A. How do we define A? We defined A as the square root of 1 minus our half side squared. And don't worry about this double star. That's just Python lingo for squared, or like to the power of. So half side to the power of 2. And then we can, let's see, we need to define B. B is our radius minus A. So now we have B. And Zach, thank you so much for following. Oh no, I have to like reopen all the windows to see who followed. And where did chat go? What adventures? All right. We don't need lambdas. So I'm going to do this in really, really simple code, and then we're going to use some recursion to estimate. And so that's where the coding gets a little bit funkier, but we're going to walk through it in simple code first. All right. So B is radius minus A. And yes, torque. No, John, don't worry about it. Don't worry about it. Also, oh no, who just followed? Levitt Yelks. Thank you so much for following. And thank you. Exactly, Big Jug Sofa. And let's see. Radius. When the definition of A is actually radius. Yes. Thank you. Yep, okay. And so we now have B. We now have our half side. So we can copy over here our math for our new side length. Okay, and that's just going to be another square root, and this time we need b squared plus our half side squared. Space it out so it's a little easier to see. All right. I'm so glad you like the colors, Big Jug Sofa. Yeah, I find when I'm learning, even when I'm doing like some machine learning models and stuff, and obviously for colorblind people, this would not be as accessible. I'm hoping that between the labels and the different lines that it's still somewhat readable. But for me at least, I can instantly kind of follow by seeing like the little blue line that is B. I can easily see where B pops up in the equations. And so kind of tying it together like that, at least for me, really helps my eye. And let's see. Sec, you ask, do you think a 25-year-old who hasn't touched math or science since high school can go back to school for physics or comp sci? Gee, I hope so, because that's what I did. I mean, I was 23. So I was 2 years younger than you. I hadn't done math or physics since high school. And I switched careers, and I went to graduate school for astrophysics. So I hope so. All right. And Belganol, well, I'm living proof that it was possible. And let's see if I missed any questions. Thank you, IHVH, for that catch, by the way. What's my favorite area of math? Calculus, by far. Or, like, I would say differential equations. But, yeah. And Dervius, thank you so much for following. Okay. And thank you for subscribing, Zach. And I'm not an outlier. I had somebody who was in their 60s in some of my graduate classes. So, and yes, B Remarch is in a dark blue. Does it look the same as A to you, or is there another color that it's similar to? I can try to be mindful of those colors. And let's see. Thank you also, Biteborn, for following. If I missed that, I'm sorry. Oh crap. I just closed the windows again. All right. Luke, I like it when I'm teaching new people. So I use just kind of like IPython in the command line when it's just me. But a lot of people really, really like being able to have the interactivity and the visual kind of nature to a Jupyter Notebook. So I found that it's a lot easier to teach programming and teach machine learning and stuff using a Jupyter Notebook for as much of it as I can, because it really does resonate with folks who are newer to programming. And JMLDVLP, thank you so much for following. For quick stuff, Zug, yeah. Or just like Vim, like a really small script, write it and then run it. And exactly, Torque, I love Jupyter Notebooks for writing notes, absolutely. And linear algebra, I use lots and lots of linear algebra, but like if you're asking me what my favorite is, linear algebra is cool. Like I use that more often than I use differential equations, but I loved differential equations. All right. Okay, so we have a new side length definition now. So we also have, if we were to take our diameter I'm actually going to do it over here before we have our new side length. We have a diameter, which is just 2 times our radius, right? And then we have, let me think about this. Then we also have our circumference, or in this like perimeter. I'm gonna use circumference because we're trying to guess the circumference of the circle. And that is gonna be our number of sides times our side length. And then we have our current estimate for pi is gonna be our circumference divided by our diameter. So our current estimate before we use our new side length, right, is gonna be 3. That's what we expected. Good. Yes. Luke, I'm trying to do really, like, oh my God, this can be a little frustrating. Math Mondays do not have code. They very, very rarely have code. So I am writing code for people that have never seen code before. I am not going to put everything in a class. Absolutely not. That is like a way to alienate a chunk of you know, the viewers who are interested in math and want to know where pi came from, but might not have the programming experience. So this is like really simple code. You can see like very straightforward variable names, all of that, so that, and yeah, I agree, a class is unnecessary. We're going to do this with a recursive method. So you don't even need the class, but, remember that, please. Like, I know there's this intuition, especially if you're more advanced in one topic, to kind of be like, why don't we do it in this advanced way? But one, there definitely is, especially in Python, an over-application of object-oriented programming. Classes are not always applicable. And two, like, you have to remember that this is an educational stream. This is for people who are at all levels. And to do that, that means I'm not going to talk over people. I'm not going to make myself look smart at the expense of the people trying to learn. So, and no, Ray March, are you able to see the B is right here? So it's that small difference between the radius of the circle and our old, like, our cutting in half line segment. Hopefully that helps. And Granofire, yeah, please, folks who are new to programming, if any of this doesn't make sense, let me know. Hopefully some of it's intuitive, like the slash is going to be to divide, the, you know, asterisk is going to be to multiply, double is an exponent, so I can even just write like a little note here, double is an exponent. So hopefully that helps, but stop me anytime, because the aim here is really to show you how to do this and continue it without having to write out pages and pages of math equations. So let's have the computer do it for us. And thank you, Zug. All right. So, did I miss anything? And Raziel, you say you have no experience also with programming. Please don't worry. Math Mondays, I try to actually not have programming, but here, in order to do this approximation, it's easiest to use programming. So please, seriously, like, you're not stupid. The questions aren't annoying. You're not going to bother me. If anything doesn't make sense, stop me. Because I'm here for all of you. And thank you so much, Online Spirit, for following. And let's see. Sugo Edeska. Thank you. Welcome. It's nice to have another viewer from Brazil. Okay. So let's see here. Where were we? Pi. Okay. So now we know our new n sides, right, is going to be 12 because we're doubling all of our sides, right? We're cutting all of our sides in half, and we're making 2 new sides from the one side we have. So we've got our new n number of sides, and we also know our new side length, okay? And our diameter isn't going to change because our circle hasn't changed, right? So we've got new sides. So our diameter is going to stay the same, but our new circumference is the new number of sides times our new side length. And so our new guess for pi is going to be our new circumference divided by our diameter. So we've gone from 3 to 3.1, 3.11 if we're rounding, or 3.106 depending on how much we want to round. We're getting closer. We're approximating pi closer and closer. So here's the next thing is, do we really want to sit here typing out new end sides, new circumference? No, that's going to be a pain. So what we're going to do is we're going to create something called a function. And in Python, this is just a pattern. It's a pattern that we can repeat over and over again. We'll do this with something called def, which is like define, right? So we want to define, let's say my function is add, okay? And I have x and y. I want to give my pattern x and y. So the sum of these, the sum of my numbers, right, is going to be x plus y. And then we're gonna give that sum back. And I know this might seem this might seem a little bit like it might seem a little bit strange if you haven't done programming before. But all this is it's a blueprint in a way, or a pattern of actions that the computer can follow. So now if I say add 6 and 10, I get 16. So it knows to expect an x value and a y value. It gets the sum of those two values, and it gives us, return means give back. It gives us back that sum of numbers. Procedure, maybe, yeah, like I'm not gonna like split hairs over words. I just want people to understand that when they see me start to define a new function, that's all that's happening, is we're creating a new pattern. And Luke, yeah, like I'm not making shorthand though, right? We are trying to be as clear as possible. Crispy343, thank you so much for following. So I'm going to be writing things, and please, like, I write Python 8+ hours a day for my job. Like, I know how to code in this language very well. I'm writing things simplistically so that the people who are in chat, who are new, who have never seen a programming language before in their lives, don't run away. You can also do everything I'm doing today, you can do it in Excel, except one part. But that's why Python is fun. All right, so let's create a new function, a new pattern, right? We want to estimate pi. And so what do we need? We need the number of sides to start with. We need the side length. And we're going to need a counter. And this is because, think about it. As we continue and we make shapes with more and more sides, guess what? Once we have infinite sides, we get a circle. Do you want to sit here as we do this into infinity? No, I don't either. So the counter is going to be our way of just checking out, being like, hey, so if we've estimated, if we have estimated 100 times, like, so that is doubling the number of sides 100 times, we're gonna exit, okay? All right. And let's see, have I ever had to use MATLAB? I did, I hated it. I'm sorry. I hated it so much. Wait, if I click do I need to toggle something? Oh, we have a new Enceladus. Hi, another Enceladus friend. Okay. So actually, before we get too much into the estimation of pi, I need a little bit more water. I like my throat's getting scratchy. So I will be right back. Don't go anywhere. When we come back, we're gonna finish writing our estimate pi function, and then we'll see how close we can get to pi, all right? So I will be right back. Don't go anywhere. More math and Archimedes and wonderfulness and pi when I come back in just like a minute. All right, I'm back. So let me set up my windows here. Need this one. I need to be able to see chat. There we go. Okay. So actually, one thing that I realized while I was getting more to drink, and Ethereal Plus, thank you so much for following, is that all of you wonderful Math Monday humans already know what a function is. I'm so silly. Duh. So this is just like, you know how you have f of like x and y? That's all this is. We just have to put a def in front so that we, the coding language knows we're making a new function. And the n sides, the side length, the counter, these are just our x and y and z. These are our variables that we're feeding into our function. Duh. I can't believe I didn't even think about that. That I didn't even have to kind of come up with metaphors and ways to explain programming functions because it's like a math function. Duh. Silly me. I'm sorry, friends. Hopefully, though, that makes sense. All right. Goodness. Okay. Gotta remember to keep my shoulders down. I need to have a, like a posture check or like a shoulders down redemption or something because, like, as I get stressed, my shoulders start to creep up. And I need to remember to keep my shoulders down. Okay. So, hopefully so far everything makes sense. Let me actually take a pause here because I know we're coding. That never happens on Math Mondays. What? There's math here, math there. How do you all feel? Those of you especially, I'm more speaking to those of you who have never coded in Python. Does this at least, are you able to follow this? I'll delete this right here, but are you able to follow this? Is it too much? Is it, completely impenetrable? I'm trying my best to make it as explainable as possible. But I want to make sure that even our wonderful community members who, are not programmers can follow this. And thank you, Loaf, but I appreciate the effort. Like, I love that community mindset of like, I want to contribute and I want to like help it be better. But right now, the really important thing is not for this to be the most idiomatic Python you've ever seen in your life. It's for it to be readable and explainable and understandable to people who've never seen code before. Like, if I do, like, for a programming stream, like, maybe then we can talk. But for this especially, I find that there's a lot of folks who do education where they find themselves pressured to perform their own intelligence more than to remain explainable. And so it's challenging because for me, what matters most is that all of you get it. I don't care if people walk away being like, she doesn't know how to code. I know how to code. I'm confident in my own abilities. But like, it matters more to me that you all understand what I'm doing than it matters that I look smart. And so even if the code seems like, would I actually do this in real code? New side length? Maybe not. But when I'm teaching, I want things to be as readable and as understandable as possible. Trixon, thank you so much for following. Welcome to Math Monday. And I also, like idiomatic code sometimes it doesn't really gain you a lot of, maybe like fewer lines, but like it actually doesn't gain you that much, but you sacrifice transparency. So I prefer to keep things simple, but simple contextually can mean different things. Here, simple means readable and understandable by folks who haven't seen code. Simple in other contexts might mean something different. Okay, so hopefully, awesome, crispy, okay. No, you're fine. As long as you're able to follow, that's what matters. Luke, I don't tend to teach general programming, but there is a lot more advanced programming when I do machine learning streams. And Devil, let's see, hold on, I can't see your name. Devil Honor, you ask, during your time as an astronomer, did you ever need to use complex analysis? Do you mean like complex numbers? If so, absolutely. If you just mean difficult analyses, also definitely. Okay, all right. So if no one else is screaming, oh God, what's happening? There's code. I can move on. But also if at any point, like I said, if anything doesn't make sense, you forget what something means, like I'm literally here for all of you. So please, please stop me. And Ethereal, you say the code is readable, but I'd have to reread the math to figure out what the code means, even though I understand the pictorial picture. That's okay. And if there's any of this math that you're like, hey, I forget, how do we get this? Just ask. Like, hey, what is that blue line again? Or what's that purple one? Like, let me know, and I can pause and just, you know, re-explain. I don't mind at all. Like, that's the beauty of a stream, a math stream, right? Is that I don't have a set schedule. I'm not trying to like give you a test tomorrow. We can take as much time as we need to talk about this. Generic crew. Oh God, what's happening? There's code. Behave, generic crew. I know you. All right. So we have kind of manually figured out what our next estimate for pi is based on having a 12-sided figure instead of a 6-sided figure. But ideally, think about it, right? What would we want to do? We don't want to have to write these lines of code out for every single, you know, n sides value. So we want to kind of have, just like in math, like a function that we can repeat and get our better estimate for pi that way. An MB dealer, I'm so glad. I'm so glad it's helpful. All right, so remember the counter. The counter here is just to make sure that we don't get stuck, because we could do this, I could let it run, it would go forever. Remember, pi doesn't stop. So we don't want to let this just go. So this is our hard stop. We're going to cut it off. We're going to say, hey, you can try to estimate 100 times, then stop. So that's our fail safe. But let's start to estimate pi. So, right, we have a diameter. We know that's going to be 2. And if you're like, wait, how do we know it's 2? Remember that we have the radius of the circle and our diameter is just 2 times the radius. So here I am like defining the radius just so we have the nope, I'm not gonna do that actually. And Enceladus, yay, 200 bits. Thank you so much. 2 dog treats. And I think with Ian Alex Hart, that brings us to 4 dog treats. So if you all are wonderful and put up with the code, then, I mean, I like the code. But if you put up with the code, we'll be able to give the dog some treats later. Okay, so actually, I changed my mind. I'm going to have... And I'm doing this on purpose. All right, so hopefully all of this looks familiar. Our radius of our circle is 1. The diameter of our circle then is 2 times our radius. Could you just, if you donate 10,000 bits, we'll dog give 100 dog treats. Usually once we hit a certain point, they get like a super fancy treat. So I think somebody donated 1,000. Like we ended up getting like 30 dog treats. So like, what is that? 3,000 bits. And so for that, like we made a plate with like peanut butter and treats sprinkled on top and stuff like that. So for a little bit, it's the amount of treats, and then once it hits a certain level, it's like the quality of the treats. Okay, so we have our radius, we have our diameter, and we need our circumference, right? And our circumference is just the number of sides times our side length, right? Hopefully that is still very straightforward. And we're going to, a print statement in Python, just kind of like printing something from your computer, it's just going to read it out. So if I were to say like print hello, it would print hello. So that's just a way for us to, as we're kind of making better and better estimations, it's a way for us to see how good our estimate is so far. Loaf One has eaten a dog treat before. I was a little cross. That was maybe not the greatest. So we're gonna say our current estimate for pi is gonna be, yeah, that's fine. Don't worry so much about this right now. This is just us printing out our estimate for pi is gonna be circumference divided by our diameter. Okay, I'm not from Tennessee, but my dog's name is Tennessee. But for the playwright, not for the state. Sorry, Tennessee, the state. And Smee Golf. Thank you so much for following. Welcome to stream. But will a for loop be in that function? Ethereal plus, so I'm not going to use a for loop. So actually it might be, here's my challenge, right? The way that I thought to do this, actually we don't need this yet. The way that I thought to do this was to do something else other than a for loop. However, a for loop will be more understandable because the way to do this effectively is actually via recursion. But I will walk you through it. Also, let's see. The REPR, the repr or whatever, represent. Let's see who asked that. Hold on. Generic crew. I'm going to give you the Python answer, and if you're like, I don't know code, because you made that comment earlier. So the programming answer is that it gives you a representational string of that particular value. And the reason why is that, as you'll see, Python kind of like has sort of an innate rounding or cutoff for the values that we're going to be printing. And by doing that, it allows us to see more decimal places. But I can also do this via the decimal library, but that makes the code a lot less readable. So I want to do it first with really, really simple code, and then we can add in some of those delicious goodnesses later. I don't come from a Greek heritage. I do not. And Belganol, you'll have to send the link to Loafbone. So, It will use scientific notation, yes, generic crew, but it rounds. And yes, Super Atom, we can edit the precision, but to do that, I need another library. And for now, to make it really, really readable for the first iteration of this, at least, we're not gonna worry about the decimal precision at first. And Anakim Luke, you can use the decimal library. So that's what I can do later, for those of you who are interested, but for now, we're gonna keep it very simple. Okay, so we have this S2, this orange, right? Actually, is that what I want? No, I need S over 2. So we'll call this, what do we call this up here? I called it half side, I think. Yeah, okay. So we have half side, and maybe just to be clear, let me go over here. And so I can write this out for people. Half side in Python is going to be S over 2. DM Loafbone, Belganol. And so that the duck though, I think the default is like 15 decimal places off the top of my head. But like this method, if you have the decimal precision, this will continue to estimate the values of pi. So, let's see. Choosing not to use decimal just people can read is going to be annoying. It won't be that annoying, honestly. Like, we get a decent enough approximation, and then I can add in that decimal library when we need it. And let's see, Martin Eden, you ask, why do we need a counter parameter? Well, think about it, right? Pi is infinite. So if I continue to force this to estimate better and better values of pi, we need some kind of way to stop it so that it doesn't just continue forever. And so there's a couple different ways you can do this. You can do it with a counter. So I'm just going to allow it to estimate 100 times. You can also specify a precision, and we could do it that way. Like, as long as you're within a certain precision compared to pi, then you can stop. So there's different ways to approach it. I did a counter for the sake of, again, readability. So this is going to be our side length divided by 2, right? Our half side, S over 2, side length. And yes, Trixon, the counter will be incremented. And let's see, what else do we need? We need A. How do we define A? We defined A as the square root of the radius minus the radius squared minus our half side squared. And no worries, duck, though. I think people know what I mean, though. But, all right. So, and then we also have b. b is equal to the radius of our circle minus the value we just figured out, a. All of that is here, over here, right? So we just did a. Oopsies. Just did a. Now we're going to do b. Just did b. Now we need to do S2, or our new side. And so our, let's see. Our new side length, right, is going to be, how do we define this? The square root of b plus our half side value squared. It's ethereal plus. There are some similarities. It's quite different in some key ways, but that would be a great thing to talk about another time. And okay, so we got a side length, and then this side length though corresponds to, remember, we're cutting things in half, so we're doubling. So our n sides is going to be equal to our n sides times 2. We're going to double our number of sides. And like, let's see, who asked about the counter? Trixon. So then we need to add 1 to our counter. And so remember how I said return is how, a function passes a value back to you? So here's where the recursion happens, okay? Is that we're going to return. We're going to use our function in the return. And I know this is going to be the hardest thing for people who haven't seen code. I could just give you pi. Like, we could just make pi a value and it returns pi. But then it would only work once. And I'd have to write a loop that would say, okay, now I'm going to go through and I'm going to feed it this many sides, this many side lengths, etc. So here, yes, Big Jug Sophie, you got it. It's not going to be able to be stopped. And so, we're going to estimate pi. We're going to feed it our new number of sides and our new side length and our counter. And this is the recursion. And so, like I said, this is going to be the hardest for folks who haven't done coding before. But what you can think of is that essentially it's going to repeat the process. Just think about it like that. So estimate pi calculates a new side length, a new value for our number of sides, and then repeats the estimation. So we're just going to keep repeating until our counter hits 100. Okay? And so let's start just like Archimedes did. We're going to start with 6 sides, and we're going to start with a side length of 1, and we are going to start with a counter of 0. We are, nope, we start with a counter of 0, and so we are just incrementing from 0 to 100. I mean, it's the same approach. So you can de-increment, you can increment, whatever your heart feels like. So here's our first, right? This is what we got over here. Our first estimation, right? 3. And then here's exactly what we got up here, right? We got our next estimation where we're like, yeah, we're getting closer. This is great. And check this out. Look at that. It's getting closer and closer and closer, right? And at a certain point, it starts to repeat because, yeah, we lose our decimal precision. Coincidence? I don't think so. Exactly, Zug. Archimedes' tablets didn't quite have the refresh rate. Well, let's be grateful for Python, because poor Archimedes did this all by hand. So, yep. Absolutely. So, let's see. Current or estimate. Yep, super atom. So you can see here, all right. So after, after 4 estimates, we're already at 3.14. So actually the other thing that would be important to show you all is okay. So our first estimate, we're dealing with a hexagon, 6 sides, and our current estimate is 3. We know that, we did that by hand. Then our next estimate, our number of sides doubles, 12, and our estimate gets a little better. Already after, let's see, what was it? 4 estimates, we're talking 96 sides, we've got 3.14. And so the point at which it bottoms out, at least for us, due to our decimal precision, which I can show you how to change, is estimate 25. But that is with, oh my goodness, 201,326,592 sides. So 200 million sided shape. And that's kind of where, we're not really, our decimal precision isn't showing us an increase. He did not use that many sides, no. Poor Archimedes, I know, right? And let's see. Can I earn a 200K SFE salary after writing this program? Could you just... I don't earn anywhere near that. So if you find a way to do that, let me know. No, but thanks, Python. Exactly, Big Jug Sofa. So now you see why I wanted to write the code is that, and you say 96 sides, and how long is one side? So I can show you. I'm gonna not print the estimate number anymore, but we'll do number of sides, and we'll do side length, and that's just side length. So, where were you talking? 96 sides? 96 sides, the side length is 0.065. Archimedes casually drawing a gazillion things and missing one side, right? That would be me. That would be me. And so you can use a double. So you can use a double data type, I think, unless I'm getting this confused with C#. But you can also use the decimal library and turn all of these into decimal objects. But that really, that removes some of the readability of the code. So, and let's see. Cootie Juice, I should stream with Loaf. I've played games with Loaf on stream before. Does Python by default use doubles? I think I'm thinking of C#. Honestly, the distinction between float and double. Getting my programming languages confused. But hopefully now you see, like, while of course we don't have pi to thousands and thousands and thousands of decimal points, we are able to estimate pi to a decent amount. Like, look at this. Like, for an approximation, I mean, that's really good. That is a very good approximation. Loaf when you could loaf around. Let's see. Yep, it's the decimal data type. Let's see. It looks like Python's built-in float type has double precision. It's basically the C language equivalent of a double. I could also use 128-bit float from NumPy, but also again, like, readability. Exactly, Big Jug Sofa. Exactly. So hopefully this has shown all of you, 1, pi's really cool. 2, pi isn't like some mystical random number. It's a number that literally just represents the ratio of the circumference of a circle to its diameter. And we have a great back of the envelope way to estimate it using polygons. Now, obviously, to get really, really precise, you need like, what was it, like 200, 300 million sides. So less practical if you all want me to try to draw that. But Space Dive, thank you so much for following. Anakim Luke, I love that. And of course, Grain of Fire, how was it readable at least? Was it were people able to follow if you weren't familiar with programming? I really hope so. I tried to keep it like so that, you know, it didn't get strayed too far into like programming, and it still really was kind of readable math. And let's see. Mediocre Gamer, you say your kid has to present to his mom when he wants something she's not super into. Just checked his pretty decent presentation on being allowed to try airsoft. Make a good argument. All right, teaching your kid to rationalize. I like it. Yep. Well, we're not gonna make it complicated today. We're gonna keep it real simple. That's the point. And let's see. Let me make sure I'm not missing anything. Generic cry, I bet Archimedes took a while drawing sides. Let's see. Did I use anything? Did I miss anything else? To be fair, they had more time back then to do all these calculations. Right? No bills to pay. Helps when you don't have to pay rent, right? Good. I'm glad, Grant of Fire, that you were able to follow this. So, you can do this on pen and paper, absolutely. It would just require like a lot more kind of handwritten math, and so I'm not going to show them how to break Jupiter. No generic crew. But we absolutely could, you know, figure this out with a calculator and by hand. But I don't think anyone wants to sit here while we try to figure out 200 million sides, right? And so I don't think Archimedes did that, Strawberry Jesus. But yeah, another way that we could do this is to have an inscribed and an outscribed polygon and subtract them and like see the difference, right? And narrow that difference more and more. To kind of give us a lower limit and an upper limit on pi. If a computer can do it, you can do it. Believe in yourself. All right. Call me when y'all hit 200 million sides. I'll see you in a while. It'll take some time. Oh no, don't Google airsoft injuries. I have scars from some teenage friends who decided it would be funny to put an airsoft gun point blank on my leg and shoot me. Big Jug Sofa. No, hopefully, in all seriousness, hopefully it was simpler to follow. Lovefun, I know you've seen a lot of my more complicated code, but how was this? Were you able to follow it? I hope so. But nevertheless, any questions about the code? Any questions about pi, about the approximation that we did, the math? This would be a good time to ask before we wrap things up. Yeah, you know, you can think about programming like languages kind of like that, like a really, really fancy calculator and then some. But the point really was to be able to follow it. So I'm glad that you were able to. I'm gonna look something up, so give me 1 sec. You're absolutely welcome. Oops, I am trying to open the wrong thing. Where's Chrome? There's Chrome. Let's see. And thank you, Zug. I appreciate it. So Ethereal Plus, there's a couple of different things. So what we could do with recursion is do kind of that precision exit that I mentioned earlier. But for loops in general, while sometimes unavoidable, are often not the most efficient way to do it. It also, to me, allows for like a little bit less prescriptive, like I'm going to iterate from this thing to this thing versus like, you know, we could have an emergency counter and still kind of do the precision. Like if it's within a certain precision value, just return pi. Otherwise, like continue to iterate. You could do stuff like that too. So it gives you a little bit more control in my mind. But you could absolutely do this with a for loop. So please do not worry. You could absolutely do this with a for loop if that feels more comfortable. All right, let's see here. All right. Yes. Ooh, that looks cool. All right. Oh no, Twitch is pooping itself. All right, so I'm gonna raid. All right. Let me set that up. So please, please, please stick around. Girl with Box is an excellent, excellent stream. Looks like she's working on a Twitch bot, which is cool. I don't even know how to do a Twitch bot. But there will be co-working streams during the day. I don't know about tomorrow. I got a lot of meetings, but Thursday, game dev. So if you're interested in C#, oh wait, 10 song. People want 10 song. All right. No, I'll pause. Would you like my dog to sing for you? If you all will stick around, I can get Tennessee, one of my dogs, and he sings for you. So yes, please. Okay, you got it. So I'm gonna be right back really fast because I gotta take down the green screen and get his his little area to sing all set up. In the meantime, let me know what you'd like him to sing. He sings any of the Star Trek theme songs except Enterprise. He'll sing Stargate SG-1 and also Stargate Atlantis. So if Loafbone can make a poll fast enough, we can do that. Otherwise, just let me know in chat. Okay? I will be right back to get his divaness. All right, bear with me. I'm gonna get a few other things figured out here. I have a Tennessee cam, so just give me one sec. So for that, I'm gonna use my co-working thing, and then we will hide the goals because we don't need those anymore. We are going to remove the cropping and this, and move the webcam over here so that you can see him. We've got 2 views of Tennessee. 2 views. All right, what did you all decide on? What song would you like? Oh, there's a straw poll. Okay, let me take a look. And let's see. Oh no! Is it broken for me? Can anyone else see the results of the poll? The poll isn't working. Okay, well, tell me in chat, friends. Tell me in chat while I get the rest of this all set up. Tennessee. Don't lick yourself bad. I know you're a good boy. Okay. SG1, Voyager, SG1, DS9. 2 votes so far for SG1. Oh, we might have come on, Hubs. We have a Hubble too. Okay, so right. Loafbone, what do you think Tennessee sings the most aggressively to? Because like that'll get Hubble singing if Tennessee's like super into it. You think it's DS9? Oh, he's like prepping. Also, I'll have you know, all of you who got treats, I've got 4 pieces of cheese here, thanks to all of you. Or SG1. Voyager's is quietest. Okay, lots of people for DS9, so let's do DS9. Oh, I know you're perfect. And I'll get out of the way. I just don't want to roll over and pause. Okay, I know you boys are perfect. You're perfect. You're absolutely perfect. Can you still see him? I'll move back even more. Hi, you boys are wonderful. You sing so wonderfully. Let's find DS9. And thank you for following 1HQ. Yeah, volume warning. I'm going to turn down the mic. Tennessee gets really loud. All right. Oh, I also need to pause the music. An ad. I'm sorry. Hold on. Everybody loved your songs. Everybody loved your songs. Here you go. Here you go. Let's see. You got Hubble Kiss. Thank you. Good boys. Good song. Yeah. You were wonderful. Everybody loved it. Everybody loved it. Such good songs. Yes, good boys. Aren't they the best? Best dogs, right? They're so perfect. Oh. Well, in any case, thank you all so much for stopping by Math Monday. Please stick around for a raid. I love to pay it forward to smaller streams and give them like support and love. So please, please, please stick around for that. There will be co-working streams during the day this week, but the next scheduled stream is Thursday night game dev. So if you have an interest in Unity or C#, please stop by. And stick around for the raid, because you know what? We gotta grow some small communities. That's the fun. All right. See you on Thursday. Bye, friends.
From their post.